Okay, so can you write a title in your red book which is rationalising surds? You need to write a title in your red book which is rationalising surds. Alright, so the thing is with rationalising surds is it basically, a lot of people when we do rationalise surds say, what's the point? Why do we rationalise surds? So I want to make it important, I want to make it clear why we used it. I did a research on it. Basically, it came way back from the Greek times. Alright? Rationalising surds, in fact, let's write this down first of all. Let's write this down first of all. Rationalising surds. Rationalising surds means to get rid of the surd from the bottom of the fraction. What's the bottom of the fraction called? Denominator. Yeah. Rationalising surds means to get rid of the surd from the bottom of the fraction or the denominator. So the problem is that we have things that look like this. We have things that look like this. Try again. Sorry, the board wasn't plugged in. We have things that look like this. There we go. We have things that look like, okay. Notice that the surd is on the bottom. The surd is on that denominator. Okay. Now, the reason we don't like that, again, comes back from the Greek times. Now, what is root 2 as a number? Somebody tell me on their calculator. Somebody tell me what root 2 is on that calculator. We've got it. So what we're actually doing here is, don't write this down. This is 3 divided by 1.4142 1 3 5. So here we've got this big, long, horrible number. This big, long, horrible number that doesn't have a repeated pattern, okay, and it just goes on forever. Okay, this is what this surd is. It's a big, what's that called? It's a irrational number, yeah. And you're trying to divide by a rational number. When you're trying to divide by a rational number, it doesn't really work. I mean, first of all, when we draw our, don't draw this, please. When we do our bus stop method, I'm going to have this massive number. And I can draw it. Yeah, that's what you're trying to do. You're trying to see how many times does that big, long, massive number go into 3, and you can't do that. Okay? You can't do that. So the reason what we do is we get rid of root 2. We get rid of the surd from the denominator. Now, to get rid of the surd from the denominator, we talked about what is the square root of Mr. Adams times by the square root of Mr. Adams. It is Mr. Adams. Now, if I want to, what can I times root 2 by to get rid of root 2? Yeah, to get rid of root 2, so to get rid of the surd, if I times root 2 by root 2, it's going to be equal to 2. We know that. Now, we can't just times by a number. We can't just times by a number. Because that number will change, obviously. If it was, let's say, think about this fraction here, 1 over 3. If I times that by 2, I end up with 2 over 3. It doesn't work like that, okay? I can't just get rid of, I can't just times by a number. What's the only number that I can times by which keeps a number the same? 1, yeah? Anything times by 1 stays the same. So that's what I've got to times by. Okay, I've got to times by 1. But I don't times by 1 is in just timesing by 1. I times by something that is 1 but looks like something else. And what I times by is root 2 over root 2. What is root 2 divided by root 2? What is root 2? What's 10 divided by 10? 1. What's 50 divided by 50? What's a million divided by a million? What is a Mr. Adams divided by Mr. Adams? What is root 2 divided by root 2? 1. When I'm timesing by root 2 over root 2, it is 1. Okay? It's not changing the number. The number's staying the same, but it's going to look different. So what is 3 times root 2? 3 root 2 all over root 2 times root 2, which is 2. And now when I'm doing this, if I was doing it, trying to work out what the number is, back in those Greek times, I would be doing 3 times by 1.4142 dot dot dot. I'm doing this today. All divided by 2. And you can do 3 times by, you can do 3 times by a big long number, can't you? And when you're doing 2 divided by a big long number, you're literally doing 2 into whatever that is. That makes sense? 2 into that big long number. We can do 2 into that big long number. Alright? We can do 2 into, I don't know, it's going to be, whatever you do. What is going on today? Okay, is everybody right with that? That makes sense, yeah? That's a bit of the backstory about why we are. Alright, everybody happy with that? Okay. Now these ones are quite straightforward. 3 root 2. Should we have a look at Dr. Frost's key skill on this? Yeah, it is quite easy, this one. But some of the other ones do get tricky, and you'll see why in a second. So let's go on to Dr. Frost. Let's have a look at a key skill. Let's go to Surds. So the first one is key skill number 685. So write down red book, please. K685. K685. Do you think you can do this on your whiteboards? Yes. I think you can. Do you want me to do it, or do you want me to do it? I will do it. I think you probably can do it. We will do whiteboards in a second. Okay. So what do I need to times this by to get rid of that third on the bottom? Yes. Root 5 over root 5. So times by root 5 over root 5. What is root 5 divided by root 5? 1, which is keeping that number same. Yeah, brilliant. And then what is 7 times root 5? 7 root 5. Watch out for the point, please. No, I can't see there. Yeah, watch out for that point. No, we'll teach you out now. What is root 5 times root 5? 5. Okay, and that's your answer. Notice that it wants it in the form A, root B over C. So in which case, what is A? 7. What is B? Root 5. No. What is A? 7. What is B? No. B is 5. The square root is already counted. Okay, B is 5. What is C? 5. Good. Alright, go on then. I will do one of these on your whiteboards. I don't think you need to do it on the whiteboards, but that's literally the one we did. Okay, have we got any on the whiteboards for these? On your whiteboard, please. I want to see it in 5 seconds. 5, 4, 3, 2, 1. Boards in the air, please. Boards in the air. Most people smash that. Yeah, good. So times 5 root 11, times 5 root 11, times 5 root 11, times 5 root 11. 8 times root 11 is 8 root 11. Root 11 times root 11 is 11. That's the answer. Now, there is one of these I want to look at, which does come up every now and again, and it's this one here. How would I do on your whiteboard, please? This one. 4 over root 2. There's an extra step to this, and you figure out what it is. 4 over root 2. What is that final step? Let me see. Boards in the air, please. Boards in the air. Boards in the air. Most people have got it. Oh, you need it. So, what is that extra little step for this one? So, times 5 root 2 over root 2. And 4 times 5 root 2 is 4 root 2. And root 2 times root 2 is 2. Now, what's the last little step? Watch out for the finger. What do I need to do here? Surds and surds and numbers and numbers. So what can we do with that 4 and 2? Divide it. What is 4 divided by 2? So this is 2 root 2 for that one there. Everyone right with that? Up and down. Okay, let's look at the next one then. So look at the next one. So, it's perfect. So, key skill number 686. Key skill number 686. So what's different about this one here? There's another number there. Okay. Now we still need to times by 1, so we know the top and bottom need to be the same whatever we times by. But there's a little trick to do this one. Let's write a little hint on the side. Hint. When we have two terms, with the surd on the bottom, we have two terms with the surd on the bottom, we change the middle symbol and multiply by this. Okay, we'll see it working in action in a second. This is where we are getting a little bit trickier though. So I will do one example of this. So it's going to be 4 over 2 minus root 2. So I times here by 2 plus root 2. But to keep the number the same, I've got to times by 1. So what was the bottom of that be? What? Yeah, 2. It has to be the same. Yeah, 2 plus root 2. Notice that I put it in brackets. Okay? That's because there's 2 terms that we're times by. And what else are we going to need to put in brackets here? What else are we going to need to put in brackets? Not the 4, because we can just do 4 times by both of those. Yeah, this is the one we're going to need to put in brackets as well. We'll start to make sense the more we do. Okay? So, what is 4 times by 2? This is going to be equal to 8. What is 4 times by 2 root 2? Plus 4 root 2. Good. What am I going to need for the denominator? What I'm going to have to use? Yeah, I'm going to have to use the grid method, aren't I? Yeah. So let's draw my grid out. In the first one, I've got 2 minus root 2. Over here, I've got 2 plus root 2. So what's 2 times 2? 4. What's 2 times minus root 2? Minus 2 root 2. What is 2 times root 2? 2 root 2. And what is root 2 times minus root 2? Negative 2. Because the square root of Mr. Adams times the square root of Mr. Adams is? Yeah, root 2 times root 2 is 2. Positive times a negative is negative. So this is negative 2. Just out of interest, when I do that, what happens with our surds? They cancel out. Okay? Because one's positive 2 root 2, the other one's minus 2 root 2. Okay? These surds here will cancel out. 1. 2 root 2 minus root 2 is 0. So I'm just left with on the denominator what two values? 4 and minus 2. So 4 minus 2 are. And what is 4 minus 2? So this is 8 plus 4 root 2 all over 2. Go on. What else? What do I not divide by 2? The root 2 because the thirds and numbers are numbers. Okay? So here, yeah, 8 divided by 2, which is 4, plus 4 divided by 2, which is 2, root 2. Root 2 is an irrational number. Everybody happy with that? What's that? Can you do anything else? Can you do 4 plus 2 root 2? What is 4 plus 2 root 2? You can't add that number in the circle, can you? Yeah? Not going to be 6 root 2, is it? Is that what you're thinking? Yeah, it's a common mistake, okay? Don't, your surd has to stay on its own and your number has to stay on its own. Everybody right with that? Should we have a go on our whiteboards? Okay, let's have a go on one of the whiteboards then. Oh, good. And your whiteboards, have we got this one here, please? Oh, it's a mistake. It's a mistake. In that little form you're trying to get it in, let's say rationalize it and take the denominator of this form. A few little mistakes in this. Pause for the air, please. Getting there. Alright, before I get to the end of this question, I want you to think about something. That works, doesn't it? 2 plus 1 divided by 2. I've cancelled those 2's. So it's 1 and 1. 1 plus 1 is 2 divided by 1 is 1. Yeah? No. Why? Why does that not work? Why can't I cancel out that 2? Go on. Yeah, 1 as well. We've got that 1 as well. I think what is 2 plus 1? 3 divided by 2, 1.5. Yeah? It's not 2. And it's because if you're dividing by 2, you've got to divide every single term by 2. 2 divided by 2 would be 1, but 1 divided by 2 is 0.5. Then it would be 1.5 over 1, which is 1.5. Yeah, you can divide both by 2, but you wouldn't because you'd end up with a decimal here. If you're dividing by the bottom, it has to go into each term. Does that make sense? Okay, let me then talk about this question. What do I need to times by on this one? What do I need to times by? 3 plus root 3, yeah. 3 plus root 3, 3 plus root 3. I'm going to do the grid method. I've got much space on here. You can do it nice and neat, nicer than me. I'll do it over here in colour. So here, 3 minus root 3, 3 plus root 3. What is 3 times 3? 9. What is 3 times minus root 3? Minus 3 root 3. What is 3 times root 3? 3 root 3. And then what is root 3 times minus root 3? Minus 3. These surds will cancel because 3 root 3 take away root 3 is nothing. And then let's do the top. I mean, I can obviously simplify that here, which is going to be equal to 9 minus 3, which is 6. You can do that if you want to. I don't mind that. But I still need to multiply the top. 2 times 3 is 6. 2 times root 3 is 2 root 3, all divided by 6. So can I now do this? No, I can't, can I? Yeah? Because I'd have to divide this by 6 as well. That makes sense? Yeah? It is a common mistake that people do it with x's as well. What was that? 6 plus 2 root 3 all over. Everything like that. That is the final answer. Okay, that's the final answer. Is he? We've got one open our book. We don't need any one, do we? No, are we all right with that? Should we do one more question? There's one harder one slightly harder. I say slightly. One of the hardest standard questions in Surds. What key skill number was that then? K687. 687. It's not time, is it? How many? Alright, K687. So, first things first. First things first. What do I need to times this by to get rid of that surd on the bottom? 2 root 5 plus 1. You change that symbol in the middle. Okay? So it's going to be times by 2 root 5 plus 1 times by 2 root 5 plus 1. Why is this one trickier? Because we've got 2 sets of double brackets. Okay, that's what makes this trickier. And we've also got these nastier surds as well, which we're going to deal with in a second. So let's do the top first. It's going to be 4 root 5 minus 2. It's going to be 2 root 5 plus 1. This first one is the trickiest, okay? What is 2 root 5 times 4 root 5? So, surds are and numbers are numbers. So, I'm going to have to do this in 2 steps. Okay? If we're doing it, I know people are going to be able to do it in their head straight away. I want to make it really, really clear. What is 2 times 4? 8. What is root 5 times root 5? So it's going to be 8 times by 5. Everybody happy with that? Yeah? If you've got the 2 surds, it's worth doing it like that. Try not to make a mistake, which is 40. Good. What is 2 root 5 times minus 2? Minus 4 root 5, you're right. What is 1 times 4 root 5? That's as well. Is that the top? Shouldn't cancel. It does. does. Really, really rubbish example. It's very annoying. It means it's not even going to be a third. Anyway, it's going to be, it is plus 4 root 2, isn't it? 4 root 5. And then 1 times by minus 2 is minus 2. So with this one, they will cancel. I end up with 40 minus 2, which is 38 on top. On the bottom, I'll do this one in a different colour. Or not. I've got 2 root 5 minus 1. 2 root 5 plus 1. Right. What is 2 root 5 times 2 root 5? What is 2 times 2? 4 root 5 times root 5 is 5. Write them separately. Think about them separately. 4 times 5 is what? 20. Good. 2 root 5 times by minus 1 minus 2 root 5 plus 1 times 2 root 5, 2 root 5. Everybody write that. 1 times minus 1 is minus 1. They will cancel. 2 root 5 minus 2 root 5. So I end up with 20 minus 1, which is 19. So my top is 38. My top is 38. My bottom is 19. And what is 38 divided by 19? 2. Very conveniently. That doesn't always happen, okay? Usually there's a third on the top. Well done, everyone. You're amazing as always.